Hello, and welcome to the video portion for the Grab Bag Lab of ME123. Today, we have a lot to cover, so let's get to it. First off is the Thin Feature option. Thin Feature is a sub-feature that exists for extrudes, revolves, and some future tools. It allows you to take your sketch and add material around the lines instead of filling the enclosed area. A good example of this is a thin cylinder. I'm going to open up a new sketch on our top plane, and we're going to draw in a circle centered on the origin with a diameter of 5 units. From here, we can go over to extrude and see that when we set the thickness to 2, we have a puck. It's extruded upwards and completely solid. However, if we were to check the thin feature option, we can see that it adds material at an offset to the sketch edges, and it gives us a few new options to play with. The standard extrude tools all work the same, and you can modify the start and end conditions as normal. The new options are down under the Thin Features menu, where we can see that we have a couple of other things to explore. First off is the directionality. The One Direction option sets up the sketch to define one of the edges of the thin feature, and if we see that it's using that edge improperly, we can hit this little reverse button to flip it around. Hitting the drop-down, we can see that there's also a midplane option, which uses the line to define the central axis of the thin feature, going in the same directions off to either side. And then there's another two-direction option, which functions just the same as midplane, but now we have control over how far it goes to each side of the sketch. Popping back over to One Direction, we now have a numerical input box that determines the thickness of our thin feature. Contrary to the name, the wall thickness doesn't need to be particularly small. We can make this value as large as we like, so long as it doesn't break the geometry. Now, there's a lot of interesting quirks to how the thin feature functions, so we're going to go over some of the common ones. When a thin feature is drafted, the draft applies to both the inside and the outside walls. Next up, we're going to need to be careful when we first create a thin feature. Occasionally, once the thin feature has been created, SolidWorks won't allow you to unthin the feature, and if you want to change it from a thin feature back to a normal feature, you're just going to need to delete the feature itself and then recreate it. Fortunately, this isn't as bad as it sounds, as oftentimes the sketch can still be saved. Another fun fact is that the sketch doesn't need to be closed in order to produce a thin feature. I'm going to go back in and we'll modify the circle to instead be something closer to a hockey stick shape by applying a pair of lines, using the trim feature to get rid of the excess, giving it an angle. Let's set this here to 120 degrees, setting the two edges to now be equal in length, and dimensioning the bottom one to be 2 units long. Now, SolidWorks is not going to allow us to turn this sketch into a standard extrude because we don't have the blue shading. However, it will let us create a thin feature out of it. We can go back over to the Features tab, select Extrude Boss Base, and we see that the Thin Feature option is selected automatically. One important thing to note is how SolidWorks deals with the endpoints of these edges. It doesn't have any information of how you would like the surface to end, so it plops in a surface that's normal to the edge at that endpoint. Another way to think about it is that it makes a right angle with the edge once it reaches the end. Now, as I mentioned earlier, this is a sub-feature for revolves as well, so let's see how that works. I'm going to go back up to the Sketch tab, and we'll apply a center line. Let's place it here, and set it so that it's vertical. Next up, we'll go back over to the Features tab, select Revolve Boss Base, and this pop-up shows up. It's letting me know that the sketch is currently open, so it will only be able to produce a thin revolve. If we hit yes, it will draw in an extra edge that connects this endpoint to this endpoint, closing the sketch, which isn't exactly what we want. So we're going to need to make sure that we hit no here. Once we hit that, we can see that SolidWorks is now going to produce a bowl-like shape out of our thin feature. Importantly, always take a close look at how the edges are being defined. If a model has an edge surface that looks like this on a revolve, it was likely created using the Thin Feature tool. Okay, on to the next tool for today, the Shell feature. Shell is fairly straightforward. Let's start by using it on a cube. Here, I have a 10-unit cube centered on the origin, produced with a midplane extrude. Let's hit the Shell button and take a look at the new menu. First, let's select the Show Preview button. This tool suffers from the poor default option that forces us to drive blind initially, so showing the preview can really help us see what it's going to do. We can see here that the Shell tool hollows out everything that we've made so far. This number box allows us to define the thickness of the shell. Not every value is going to work. Some particularly high values will definitely not work geometrically, but so long as you're reasonable, it should usually function fine. This blue box allows us to determine which surfaces get removed. The Shell feature works fine without having anything selected, but it's a really nice added bit of functionality. One thing to note is that the faces that will show up around the moved surfaces are coplanar with the removed surfaces, so we don't get any of the weird normal surfaces like the ones that we got with our thin feature. Anyway, we can see that with these two surfaces selected, we can hit our green checkbox to leave us with this rather uncomfortable looking modern chair. This leads rather nicely into the third and fourth tools that I want to cover, Fillet and Chamfer. These two work very similar, so I'm going to start with the easier one. Fillet allows you to round off edges. Let's start by taking away some of these sharp crevasses inside of the chair. The fillet feature lives up here, rather close to the shell feature, and when we select it, we can choose which edges or surfaces we want to fillet by making sure that we have this blue box selected and left-clicking on them in the view window. Similar to the shell tool, this also defaults to not showing a preview, so setting our view to full preview can really help make it so that things are easier to see. As you can see, with angles below 180 degrees, SolidWorks is going to add material to sort of smooth out those corners. The amount of material that's added or removed is defined here by the fillet radius. A larger radius is going to equal a larger fillet, and vice versa. For the purposes of this class, all of the fillets that we produce are going to be using the symmetric fillet option, and we will be avoiding the multi-radius fillet option. The multi-radius fillet has the drawback of not being able to control the separate fillets individually, which is something that we're going to be getting into more later when we cover configurations and editing. Let's finish selecting these interior edges, and then hit our green checkbox to finalize. Additionally, for safety purposes, we should probably round off these corners as well. We can open up a new fillet, and then left-click to select the edges. One nice thing about fillets is that you can affect multiple disconnected things with a single use of the fillet feature. As we can see, I've rounded both of the corners off with just one application of the fillet tool. Additionally, we can see that fillets applied to angles above 180 degrees remove material, effectively sanding down the edges of the shape. In general, you're going to want one fillet feature per specified fillet radius on whatever drawings you're working on. Now, before we move on to chamfers, I have a few things to mention regarding the interactions between fillet and shell. The orders that these two features are applied in can do some interesting things with the end result. Let's begin by getting rid of these initial fillets and creating some new ones. As you can see, if we apply some fillets to the exterior edges of our shape, adjust our radius to something a little bit larger to make it a bit easier to spot, and then finalize, the fillet functions about the way that you would expect, rounding off the exterior edges but leaving the interior edges untouched. However, if these fillets were to have been applied before the shell feature, we can see that the fillets have now changed what the inside of the shelled object looks like. It's important to keep the order of when you apply features in mind. If you see fillets inside of the shelled object, the fillets must happen first, and vice versa. If the weight of your part is off or if something doesn't quite look right, always check the order of your features first. We will get further into editing the order of features in the next lab. Now, on to chamfers. The chamfer feature lives in the drop-down directly below fillet. Chamfer functions pretty much exactly the same, except instead of rounding the edges, it just cuts the edges straight off. Here we can see that chamfer uses a distance and an angle to help define the triangle that it uses to carve out the edges. This also brings up tangent propagation. While this box is checked, a chamfer or a fillet will continue past the initial edge that was selected, going around your object until it reaches a kink, or a point where there is no longer a smooth path. This is another one of the convenient options that allows you to fillet or chamfer a large number of edges without needing to select them individually. We can even change the directionality of chamfers. This allows you to determine the surface that the distance is measured from, and it allows you to set your zero surface for the angle measurement. Flipping directionality for your chamfers really only makes sense when we don't have a 45-degree angle. So let's change this to 60 and bump our distance down to 0.2, and we can see here that by flipping the directionality, we can change how exactly the chamfer is being applied, with the little pink arrow specifying the direction that the distance is being measured in. The last tool for today is the hole wizard. The hole wizard feature is a very useful tool in the real world. First, it exists on the Features tab, right next to Extrude Cut. The hole wizard cuts out a hole that specifically matches the profile of a standard mechanical fastener, often a bolt or a screw. When we first select the tool, there's a lot to look at, so let's go from the top down on the menu. First, we can choose a hole type. Counterbore and countersink are the two main hole types that we will be using in this course, as they define how the top of the fastener hole is designed. Counterbore has a little flat platform where the hole changes from a larger diameter to a smaller diameter, and countersink has a sort of conical shape at the top, which is a fairly common head shape for wood screws. The other hole types can be useful in industry, but we will not be exploring them for this course. Continuing down, we can choose the standard and the type of fastener we will be using. SolidWorks has an enormous database of all of the standard fastener sizes and all of their different types, allowing you to automatically match the size of the hole to the size of the fastener you want to use. This is a very powerful feature of the tool, but for simplicity on the assignments, we're going to be using this Show Custom Sizing option for the purposes of this course. In order to activate the custom sizing, we need to check the Show Custom Sizing box. Each hole type comes with its own options, so make sure that you have the hole type that you're looking for selected before we start filling in our sizes. Finally, down at the bottom, we can select our end condition. This works exactly the same as the end conditions for standard extrude cuts, with one new wrinkle. While using a blind end condition, we can choose if the given distance defines the depth to the tip of the hole or the depth to the shoulder. One thing that you'll notice is missing on this menu is something to define the angle of that little cone at the bottom. That is because the cone is chosen to match up with the angle of the standard drill bit, or approximately 118 degrees. After you've already positioned and finalized your hole wizard, you can sometimes go back and change it when you're using the blind end condition. But for our purposes, if something does allow you to set the angle at the bottom, you can always leave it at 118 degrees. There's always going to be a hole callout whenever we expect you to use the hole wizard. Here is a good set of examples of what each callout does and how the hole profiles look. This image is available on Canvas under the SolidWorks textbook and lab resources next to this chapter. Do feel free to look that up whenever you're having trouble with these things. Now, as to what the callout does, let's go through one step by step. The first line is going to tell us the through hole diameter and how far it goes. This diameter is going to get placed in the first box, here, and the depth is usually defined based on the end condition. In this case, through stands for through all, or occasionally up to next, depending on what's going on in the drawing. All of the remaining lines talk about the near side details. The upside down staple shape tell us that the hole is going to be counterbored, with the diameter and depth for that option displayed next to it. The stretched out V shape means that it's countersunk, and it gives us the given diameter and the angle that we can set into the relevant input boxes back on the hole wizard. Now, after all of this, we've told SolidWorks how we want our hole to be set up, but we haven't told it where we want the holes to be. For this, we're going to go over to the Positions tab at the top of the menu. Once on this tab, we're going to ignore the 3D Sketch button and just directly select the surface that we want our holes to start on. From here, we can use the Sketch Point tool to select the locations of the holes. By placing multiple sketch points, you can create multiple holes with a single application of the hole wizard, making it easy to define all 4 of them at once, while only using a single feature. One thing to note is that this is producing a sketch, so that means that we're going to need to make sure that we fully define the locations of these sketch points. Do remember that it is also important that we don't reuse any dimensions. A general rule of thumb is that we should have a number of hole wizard features on our design tree equal to the number of hole callouts in the drawing. But to go about positioning these holes, let's create a construction rectangle centered on our origin there, making sure that we check the For Construction box in order to make sure that SolidWorks does not get overly confused with what's going on. And then we can use our Smart Dimension tool to set our distance. Let's set this so it is 3 units tall and set the 2 sides to be equal in order to make sure that we have a square. And then we can use Coincident to set each one of our sketch points to match up with one of the corners of our square. Once we've fully defined the positions of all of our hole profiles, we can then hit the checkbox to finalize the feature. One thing to notice is that we now have a little drop-down button next to the hole wizard, and we can see that it's generated 2 sketches. The first sketch is often going to be the one that defines the locations, and this one you can edit freely, but the second sketch is generated by the hole wizard feature. If you ever do want to modify your hole profiles, instead make sure that you right-click on the hole wizard feature and select Edit Feature. Then from here, we can go back into our custom sizing menu and change these values to modify that sketch. There we go. That gives us a pretty good overview of all of the tools for this lab. So here are a few hints on how to use them. Order is very important with all of these. There's a large difference between doing the hole wizard after the shell feature versus doing the hole wizard before the shell feature. Shell is applied to everything that you've done so far, so if a feature is solid, that means that it needs to happen after the shell. Fillets and chamfers can carry through shell features, so make sure to apply them before the shell if you see them inside of the shell. Otherwise, they're likely applied afterwards. Occasionally, the hole wizard itself will automatically check a few boxes down near the bottom. If your hole looks strange, make sure that all of these boxes are left unchecked. To reiterate on what was mentioned earlier, if the hole wizard is not set to through all, you can get a conic shape at the bottom of the hole. The angle for this cone is set to 118 degrees, the industry standard for drill bit tips, and sometimes it doesn't show up initially. This 118 does not count as a used dimension. If a hole shows up in the part and it has a cone shape at the bottom, the 118 is implied, and you won't get docked for using it. So, that about covers everything that I wanted to talk about for this lab. Each one of these tools has some tricks and tells that you pick up with usage. So as always, practice and experiment to learn how to use them as best you can. Have a good day. We will see you again next time.